Good day everyone. For today we're going to discuss solving rational equation. The learning objectives are as follows: solve rational equation and solve problems involving rational equations. In the previous discussion, we defined rational equations as an equation containing at least one rational expression, and these are the examples. To solve for rational equations, we usually solve or find the value of the variables and determine whether the value of that variable is a solution set to the given rational equations or simply an extraneous solution. But what is the difference between solution and extraneous solution? A solution is an apparent solution that satisfies the given equation, while an extraneous solution does not solve or does not satisfy the equation, meaning they are values of the variable that you have solved, but when you substitute the value to that entire rational equation, a solution will make it equal. But an extraneous solution will not make the entire equation equal. Here are the steps in solving rational equation. First, we factor all denominators if possible. Next, we get the restrictions by locating the x value, which will make the expression undefined. We do this by equating each denominator to 0 and then solving for the value of that variable. And then we find the LCD and then we multiply each LCD or each term of the equation by the LCD. So we have here LCD divided by denominator times the numerator. And then we solve the resulting equation. And then we're going to determine the solution set and the extraneous solution. And we do the checking. Let's have example number 1. Solve x over 3 plus 12 over x is equal to x minus 2. So we are asked here to find for the value of x. Okay, so the first step is to factor the denominator. But since this is already prime, so we move on to the next step, which is we find the restrictions for the variable x. So here you have here x in the denominator. So the restriction would be x shouldn't be equal to 0. Because if x is 0, this will be undefined. And then we determine the LCD. So the LCD for 3 and x is 3x. So we multiply the entire equation by 3x. And then we multiply each term. So we will have here 3x divided by 3, maka-cancel. You will have the remaining x multiplied by x. And then 3x again divided by x, you will have 3 times 12. So you will have 3 times 12. And then here we will have 3x times x, and then you will have 3x times negative 2. So you will have this one. To simplify this, we will have x squared plus 36 is equal to 3x squared minus 6x. And then we transpose everything, this one, to the other side. So that will give us 3x squared minus x squared minus 6x. So we arrange them already. And then you have minus 36 is equal to 0. Combining similar terms, you will have here 2x squared minus 6x minus 36 is equal to 0. Since this is quadratic, meaning you have two values of the variable x, we can determine the value or the values of the variable by using the factoring method. So we can factor out 2 as the greatest common factor. So you will have 2 times the quantity x squared minus 3x minus 18 equals 0. Okay, let us continue here. So we have here the factor. And then we will still factor x squared minus 3x minus 18. So this is quadratic. So we will have here two binomials as the factors. So that will give us 2 times the quantity x minus 6 and x plus 3 is equal to 0. So the next step is to equate each factor to 0. So we will have x minus 6 is equal to 0 and x plus 3 is equal to 0. Solving for x, this will be equal to x is equal to 6, and the other one will be x is equal to negative 3. Since the only restriction is 0, and we solve the number that we have solved is x, 6 and negative 3, so meaning these values 6 and negative 3 are solution set to the given equation. Okay, since we determined the solution set, we can do now the checking. So we have here, let's solution set 6 and negative 3. So let's use first x is equal to 6. So we'll have here, replace x by 6. So you have 6 divided by 3 plus 12 over 6 is equal to 6 minus 2. So 6 divided by 3 is 2, plus 12 divided by 6 is also 2, and then you will have 6 minus 2. 2 plus 2 is 4, and 6 minus 2 is 4. So 6 is solution set. Now for x is equal to negative 3, we will have negative 3 over 3, and then 12 divided by negative 3 is equal to negative 3 minus 2. So we replace all the x's by negative 3. So this will be negative 1 minus 4. And you will have negative 3 minus 2, so we will have negative 5 is equal to negative 5. So therefore, 6 and negative 3 are solution set. Okay, let's have another example, this example. So again, the first step is to factor the denominator. So this one is okay, also this one. This one is a difference of 2 squares, so we can factor this one as x plus 1 and x minus 1. Then second step is to find the restriction since all the denominator has the variable x. Okay, so we're going to equate each factor by 0. So when we solve this one, this would be x is equal to 1. This one is negative 1. This one is also negative 1, and this one is also 1. So therefore, the restrictions are 1 and negative 1. So meaning we cannot have a value of 1 and negative 1 since this will make the expression or the equation defined. Now, we determine the LCD. So you have here x1 minus x, x plus 1, x plus 1, x minus 1. So we can use x plus 1 and x minus 1, multiplying the entire equation by x plus 1 and x minus 1. Same process, LCD divided by the denominator times the numerator. So here we can cancel x plus 1 and x minus 1, but we will have a negative answer. So we'll have negative 1. So multiply it by negative 1 and x plus 1, the remaining factor. So we will have negative 1 times the quantity x plus 1. And then next, this one, the whole equation is still the whole LCD by x plus 1. So makakancel naman si x plus 1, matitira si x minus 1 times positive 1. So you will have plus 1 times x minus 1. Okay, and then next, here, divided by the LCD, divided by the denominator, so makakancel lahat yan. And then matitira lang sa atin is 1 times the numerator, 4x plus 2. I hope you follow the procedure. And then we simplify this one. So distributive, negative 1 times x, and then negative 1 times positive 1. And then we do also here. And then we copy this one. So we will have here negative x minus 1 plus x minus 1 is equal to 4x. So we can cancel this out. And we will have the remaining negative 2 is equal to 4x plus 2. Transpose or combine similar terms, we will have 4x is equal to negative 4. Divide both sides by 4, so we'll have x is equal to negative 1. So the value that we have solved is negative 1, but negative 1 is a restriction. So therefore, here we can conclude that there is no solution set. X minus 1 or x is equal to negative 1 is an extraneous solution since it is included in the restriction. This is the value of x but will not satisfy this entire rational equation. So there is no solution set. Negative 1 is an extraneous solution. Okay, let's have the next example. Solve for x over 2x minus 3 equals 3x over x plus 11. First step is to factor the denominator, but since this is prime, so the next step is to find the restrictions. of the denominator. So we have here 2x minus 3. Equating this to 0, we will have 2x minus 3 is equal to 0. Therefore, your x is equal to 3 over 2. And for this one, you have x plus 11 is equal to 0. So you will have negative 11. So the restrictions are 3 over 2 and negative 11. And then we find the LCD. So the LCD will be these two, 2x minus 3 and x plus 11. Or, since there is only one rational expression to the left and to the right, we can do cross multiplication. So we do cross multiplication here, which is the same as multiplying the whole equation by 2x minus 3 and x plus 11. So cross multiply, we will have x times x plus 11 and equals to 3x times 2x minus 3. So this will give you x squared plus 11x and 6x squared minus 9x. Combining similar terms, we will have 6x minus x transpose this one. This one, x squared plus 11x to the right side. So this will be 6x squared minus x squared minus 9x minus 11x. That will give us 5x squared minus 20x is equal to 0. So again, this is quadratic. So we have two values for x. Using factoring, we will have the greatest common factor 5x times the quantity x minus 4 is equal to 0. So equating the two factors to 0, so we will have 5x is equal to 0 and x minus 4 is equal to 0. Therefore here, dividing both sides by 5, we will give us x is equal to 0 and here x is equal to 4. So we solve for 0 and 4. The restrictions are 3 halves and negative 11. So therefore these two are solution set. So 0 and 4. Okay, for the checking, all we have to do is to substitute the solution set. If x is equal to 0, so we will have here 0 over 2 times 0 minus 3 will be equal to 3 times 0 over 0 plus 11. So this will be 2 times 0 is 0 minus 3. So that will give us 0 over negative 3. And here we will have 0 over 11. Okay, so that will give you 0 is equal to 0. And then if x is equal to 4, so we'll have 4 times 2 times 2 over, or 2 divided by 2 times 4 minus 3 is equal to 3 times 4 divided by 4 plus 11. So this will be 2 times 4 is 8 minus 3 is 5. So this will give you 4 over 5. And then here you have 3 times 4 is 12. And then 4 plus 11 is 15. So if we're going to reduce this one, this is divisible by 3, so that will give us 4/5 is equal to 4/5. So therefore, 0 and 4 are the solution set. Okay, let's have this example. Again, the first step is to factor the denominator. So x minus 2 is prime. This one is quadratic trinomial. We can factor this out to x plus 3 times x minus 2. And then this one is also the same. So the common factor for the denominator is x plus 3 and x minus 2, which will be our LCD. But first, we have to find the restrictions. So we equate all these factors to 0. So this will be x minus 2 is equal to 0. This will be positive 2. This will be negative 3, positive 2, and negative 3. So therefore, the restrictions are positive 2 and negative 3. And then we proceed by multiplying the whole equation by the LCD. So multiply this by x plus 3 and x minus 2. So we will be using this one. And then again, LCD divided by the denominator. So x minus 2, x plus 3 divided by x minus 2, makakancel yung x minus 2. So we will have the remaining x plus 3 times 2x minus 5. And then again, this one divided by here, which is this, ito rin yung factor niya. So cancel out lang yan, that will be equal to 1 times the numerator x squared plus 1. So you will have plus x squared plus 1. And then here, on the other side, so we will cancel out x plus 3, that will be equal to 1. So remaining is x minus 2 multiplied by 3x plus 8. And then we simplify this by distributive property or multiplying two binomials. So we'll have x times 2x is 2x squared, and then x times negative 5 is negative 5x, and then this one is positive 6x, and then this will be negative 50. So that will be our answer. And then bring this down, that will be x squared plus 1. Okay, I hope you follow the steps. And then here, we do the same. So you have 3x squared, and this will be positive 8x. This will be negative 6x, and then you will have negative 16. So, yan. And then, we can add this one, 2x squared, and then positive x squared. And then when we transpose this one, this will be negative 3x squared. So we can just simply cancel them out. And then we simplify negative 5x plus 6x. This will be x. And then negative 15 plus 1 will be negative 14. So x minus 14. And then here you have negative positive 8x minus 6x is 2x. And then we copy negative 16. And then combining similar terms or transposing, you have 2x. This will be minus x. And then that will give you x, and then 14, negative 14 plus 16, that will give you positive 2. So x is equal to 2. But 2 here is a restriction. And we solve for the value of x, which is also 2. So therefore, 2 is an extraneous solution, and we don't have a solution set. Okay, let's have the last example. You have 4x minus 6 divided by 2x minus 3 is equal to 7 over x plus 1. So again, there is only one rational expression on each side. So we can do cross multiplication. But before that, we have to determine the restrictions. So here we have 2x minus 3 equate to 0. That will give you 3 halves. And here, that will give you negative 1. So that will be our restrictions. And then again, as I've said earlier, we can do cross multiplication here. So we'll have 4x minus 6 is equal to 7 times the quantity 2x minus 3. 4x minus 6 times x plus 1. This will be, we can use FOIL method, distributive property. So this will be 4x squared. This will be positive 4x. This will be negative 6x, and then you will have negative 6. Okay, so, and this will give you 14x minus 21. Okay, then combining similar terms, we can have, or we can simplify this one first. So that will give you 4x squared minus 2x minus 6 is equal to, transpose this one, 14x negative plus 21. And then combining again, that will give us 4x squared minus, this will be negative 2x negative 14x, that will give us negative 16x, and then negative 6 plus 21 is positive equals 0. And then the factors for this will be 2x minus 3 and 2x minus 5. So if you do the checking, this is negative 6 and this is negative 10, that will give us negative 16x. Okay, and then we equate this one to 0, these two factors. Okay, let's continue here. These are our factors. So we equate this one to 0. So that will give us 2x minus 3 is equal to 0 and 2x minus 5 is equal to 0. So transpose this one, that will give you 2x is equal to 3. Divide both sides by 2, so x is equal to 3 halves. And this one is 2x is equal to 5. Divide both sides by 2, we will have x is equal to 5 halves. Again, our restriction is 3 halves. And we solve for 3 halves, so therefore 3 halves is an extraneous solution, while 5 over 2 is a solution set. So we have solution set 5 halves and extraneous solution 3 over 2. Okay, let's do the checking for the solution set 5 over 2. So this, we will replace all the excess here by 5 halves. So that will give us 4 times 5 halves minus 6 divided by 2 times 5 halves minus 3 is equal to 7 divided by 5 halves plus 1. So this will give you 4 divided by 2 going down. That will be 2 times 5 is 10 minus 6. That will be 4. And then for the denominator, you will have 2 divided by 2 is 1 times 5 is 5 minus 3. So that will give you 2. So that will be 4 over 2. And here naman you will have 7. And then 5 halves plus 1 is equal to 7 halves. or this is the same as 2 over 2. So 5 over 2 plus 2 over 2, that will give you 7 over 2. And then when we simplify this, 4 divided by 2 is 2. And then here you can have the reciprocal of 2 over 7, 7 over 2, which is 2 over 7 multiplied by 7. So we can cancel 7 here, so 2 is equal to 2. So therefore, 5 halves is a solution set. Let's have some application problem. So we have here number problem. The denominator of a fraction is 2 more than the numerator. If 1 is subtracted from both numerator and denominator, the resulting fraction has a value of 1/2. Find the original fraction. So for the problem solving, the first thing that you're going to do is to represent the unknown. So here we are looking for the original fraction. So a fraction has two parts, so we can represent them first. So the first condition will give you the idea on how to represent it. The denominator of a fraction is 2 more than the numerator. So for instance, let's represent x as your numerator, and your denominator will be 2 more than the numerator, so that will give you x plus 2. So your original fraction can be represented by x over x plus 2. Now, to form the equation, we will be using the second condition. It says here that if 1 is subtracted from both numerator and denominator, the resulting fraction will be 1/2. So we will subtract 1 in the numerator, so you will have x minus 1, and then 1 in the denominator, you will have x plus 2 minus 1 is equal to the resulting fraction, 1/2. And then if we're going to simplify this one, that will give us the equation x minus 1 over x plus 1 is equal to. Solving for this one, we can do cross multiplication. So we will have 2 times x minus 1, that will give us 2x minus 2. And then here you will have x plus 1 times 1 is still x plus 1. And then combining similar terms or transpose here x to the left side and negative 2 to the right side, that will give us 2x minus x is equal to 1 plus 2, or x is equal to 3. So here we can do now the checking if this satisfies the equation. So we substitute 3 here. So we will have 3 minus 1 over 3 plus 1 is equal to 1/2. So 3 minus 1 is 2, 3 plus 1 is 4, so 2/4 is also 1/2 is equal to 1/2. But you are asked to find the original fraction. So since x is 3 and your x is numerator 3, and then your denominator is x plus 2, so therefore the original fraction is 3 over 5. So this is our final answer. Okay, this time let's have work problem. If you still remember your high school mathematics, Yana can do a job in 12 days. After she has worked for 4 days, she is joined by Jenica. They finish the job together in 2 months. How long will it take Jenica to do the whole job by herself? So if you still remember the table for work, that is rate times time. So we'll have here Yana and Jenica. So Yana can do a job in 12 days. So meaning the rate of Yana is 1 over 12. And then after he has worked for 4 days, she is joined by Jenica. They finish the job together in 2 more days. So meaning Yana worked for 4 days plus additional of 2 days, so that will be 6 days. While Jenica only worked for 2 days before they completed the job. So the question is, how long will it take Jenica to do the whole job by herself? So Jenica's rate is unknown, so we will represent this one as 1 over x. Okay, and then work is simply rate times time, so we have 1 over 12 times 6, that will give us 6 over 12 or 1/2, and then this will be 2 over x. The rate is always a fractional part since this is work problem. Whatever part Yana finished in a certain job added to the part finished by Jenica, that will only be equal to the whole job. Okay? Okay, let's continue here. As I've said earlier, whatever part of the job finished by Yana added to the part finished by Jenica will be equal to the whole job, which is 1. So our equation will simply be 1 half plus 2 over x is equal to 1. Solving for this, we multiply this by the LCD, which is 2x. So we'll have this one. So 2x times 1 half, that will be equal to x. And then 2x times 2 over x is 4. And then 1 times 2x is 2x. Or, solving for this, we will have x is equal to 4. Therefore, Jenica's rate is 1 over 4, or Jenica can do the job alone in 4 hours. Okay, for the checking, we simply substitute 4 here. So we'll have 1 half plus 2 over 4 is equal to 1. 1 half reduced to lowest term is 2 over 4 reduced to lowest term is also 1 half. So we'll have 1 half plus 1 half is equal to 1, or 1 is equal to 1. Therefore, again, Jenica's rate is 1 over 4, or he can do the job alone in 4 hours. Okay, let's have the last one. We have motion problem or distance problem. So an express train travels 150 kilometers in the same time that a freight train travels 100 kilometers. If the express train goes 20 kilometers per hour faster than the freight train, find the rate of each. So since this is a motion problem or a distance problem, we can represent first the given. So let's have an express train travels 150. So this will be the distance of the express train, and 100 will be the distance for the freight train. Now, if the express train goes 20 kilometers per hour faster, so meaning this is the rate of the express train, 20 kilometers more or faster than the freight train. So therefore, let R be the rate of the freight train. Your R plus 20 will be the rate of the express train. So writing it in a table, we will have it this one. So the distance of the express train is 150, 100 for the freight train, and then the rate of the express train is R plus 20, and then R for the freight train. Now we know that distance is equal to rate times time, and if we are looking for time, we simply divide distance by rate. So we will have 150 over R plus 20 for the express train, and then we will have 100 divided by R for the freight train. So to have the equation, so since they travel at the same time, so we will simply equate these two. Okay, so this is the table for our equation since they travel the same time. So that is simply 150 over R plus 20 is equal to 100 over R. Solving for this, we can have the LCD R plus 20 and R, but we can also do again cross multiplication. So this will give us 150 times R is 150R, and R plus 20 times 100 is 100R plus 2000. And then we transpose 150 minus 100R, that will give you 50R is equal to 2000, dividing both sides by 50, so R is equal to 40. So to answer the question, what is the rate of each train? So the rate of the freight train is 40 kilometers per hour, while the express train is 60 kilometers per hour. To do the checking, we just simply substitute 40 here in the equation here. So you will have 150 over 40 plus 20. This will give us is equal to 100 over 40. So this will be 150 over 60 is equal to 100 over 40. When we reduce this one, 150 over 60 and 100 over 40, you will get 5 over 2. So they are equal. So this is our final answer. Express train 40 kilometers per hour, and freight train's rate is 40 kilometers per hour, and express train's rate is 60 kilometers per hour. Okay, that ends our discussion. Please see the next video for solving rational inequalities. Thank you.